Hello students, I am Nisha Nair. In this video, we are going to learn another bond which is coordinate bond and van der Waals force of attraction. What is coordinate bond? It is just like a covalent bond which we have learned in previous lecture. What is covalent bond then? Covalent bond means mutual sharing of electrons between two similar or dissimilar atoms. Here sharing take place between mutual sharing take place means both atoms contribute equal number of electrons. Now in coordinate bond you can see here sharing take place. It is just like a covalent bond. Here also sharing take place, but in coordinate bond one of the atom will contribute both the electrons. Not mutual sharing, but only one atom will contribute electron to have a sharing and to form a bond. So we can say as coordinate bond is a type of covalent bond where the sharing of electrons is contributed by one of the atoms. Now let me see one example here as a and B. Now in A you can see as a donor atom and B as a acceptor atom. Here A and B combine together to form a AB molecule. But you can see A and B are getting into a bond. There is a bond occurring between A and B. But for occurring the bond between A and B, A is contributing its 2 electrons to B. So here both the electrons are contributed by atom A. So it is known as a donor, and it is given to it is shared between the A and B. So B is written as a acceptor. So here coordinate bond occurs between A and B where A atom contributes both their mutual electrons to form a bond. Now example for coordinate bond is SO3 molecule, sulfur trioxide, where you can see 3 oxygen atom and 1 sulfur atom. In this molecule, one oxygen will have a covalent bond. Covalent bond means one oxygen will contribute 1 electron and sulfur will also contribute 1 electron, and they will have a mutual sharing and will form a covalent bond. But another 2 oxygen atom doesn't contribute any electrons, but they form a bond with sulfur atoms, and that bond is known as a coordinate bond because here electrons is contributed by sulfur. So in sulfur trioxide we can see there are 2 coordinate bond and 1 covalent bond. So we can say coordinate bond as a covalent bond, but here electron is contributed by one of the atoms. Here also sharing take place between the atoms, but contribution of electron will be taken by only one atoms. Another example for coordinate bond we can see as an ammonia molecule. SO3 molecule is also one example for coordinate bond. So this is an explanation related to the coordinate bond. Now let me move to another bond which is known as a van der Waals force of attractions. It is not a bond but is a force of attractions. Here for van der Waals force of attractions there are 2-3 criteria which should be followed. For example, first criteria is it depends upon number of electrons, then the structure of molecule, and third how much surface area is exposed. So for van der Waals force of attractions we can take an example of sulfur molecule and phosphorus molecule. Sulfur molecule is written as S8 and phosphorus molecule as a P4. So sulfur has larger number of electrons comparing to the phosphorus. So that's why in sulfur van der Waals force of attraction is more compared to the phosphorus molecule. So sulfur molecules have higher melting point than phosphorus. Higher means 3 times higher than phosphorus molecule. So if molecules have more van der Waals force of attractions or large van der Waals force of attractions, they will show higher melting point. So in sulfur and phosphorus molecule, if we compare, sulfur molecule has higher melting point because sulfur has larger number of electrons, its surface area is high compared to phosphorus, therefore sulfur has higher melting point than phosphorus.